Now we're looking at conjectures and the idea of inductive reasoning. Inductive reasoning is where you might think you see a pattern, so you investigate it, and once you see the pattern, you make a conjecture about it. A conjecture is just basically an unproven statement. In our minds, we think it's correct just because we've done it for specific examples, but we haven't proven it's true all the time. So a lot of times this is how we figure out connections between things, but it isn't the best way to prove things are true. For this example, we're given 5 collinear points. We want to make a conjecture about the number of ways to connect different pairs of points. So what we would want to do here is make a table and look for a pattern and try to see how the pattern is connected, so then we can make a conjecture. So in this case, we have 1 point shown here. There are 0 connections because there's only 1 point. 2 points gives us 1 connection. 3 points gives us 1, 2, and 3 connections. 4 points gives us 1, 2, 3, 4, 5, and 6 here. So if we look for the 5th one, we don't necessarily need to connect these or show the connections because we can see the pattern here. We added 1, then added 2, then added 3. So here, if we follow that same pattern, we would add 4 here, and this would give us 10. And just to test it, we have 1, 2, 3, 4 connections, and then 5, 6, 7 connections, 8 connections, 9 connections, and 10 connections. So our pattern here again is for we take the last number and we add 4 to it to get our 10 different ways. If we were to go all the way up to 7, what we do is we look at it when it was 10 for 5 connections, and we would have to add 5 this time. That would give us our 15 for 6 connections, and then we would add 6 to it, and that would give us 21 for 7 collinear points. So that's how we would do that. Just use the same pattern again, and we would have 21 different ways. For this next one, we're looking at consecutive integers. These are numbers that are in a line. We want to make and test a conjecture about the sum of any 3 consecutive numbers. So what we do is we just add any 3 numbers that are consecutive and see what we get for an answer. And they've done that here. We do 3, 4, and 5, and we get 12. 10, 11, and 12 gives us 33. 7, 8, and 9 gives us 12. Does not give us 12, gives us 24. And 16, 17, and 18 gives us 51, which is 17 times 3. If you notice, not only is it every single number a multiple of 3, but, and I apologize for the mistake here, this is actually 24. But if you notice, 4 ends up being the middle number here, 11 ends up being the middle number here, 8 is the middle number here, and 17 is the middle number here. So not only do we get a multiple of 3 when we add consecutive integers, but it also ends up being 3 times whatever the middle number is. So that's our conjecture. Our conjecture would be the sum of any 3 consecutive integers is 3 times the second number. And if we're not sure, we test it a little bit more. So we try it with -1, 0, and 1 to try it with smaller numbers and negative numbers. We get the same thing. It's 0, which is the middle number here. And we do 100, 101, 102 gives us 303, which is 101 times 3. And for this next one, we want to look at the sign of the product of any 3 negative integers. Well, hopefully we know the answer to this. If we multiply 3 negative integers, we would get a negative number as well. And here's one test for it. A negative times a negative is a positive, times a negative gives us a negative. And that's it for this one. Thanks.